Hello, everybody. This is the presentation from Project 3D Printer Group 14729. So our team from left to right is Peter Van Zeitz, Alan Su, Jacob Williamson, Victoria Belomo, Matt Allen, and Justin Rogers. Our problem in the background is to design and modify a Prusa 3D printer to be capable of printing continuous carbon fiber. This includes a robust cutting system for cutting the carbon fiber, a weighting system to combine the matrix and carbon fiber, and a control system to drive the 3D printer and all subsystems. If you were to look onto the left, you see a graph for tensile strength and elastic modulus. You can see the short strand carbon fiber versus the continuous carbon fiber, which has a clear mechanical advantage. If you were to look onto the right, that's a tensile test machine, which we'd be using to test our results. So our project goals are to fully impregnate 3K carbon fiber tow, have a complete system cured post-printing, and utilize both UV and thermal cured resin. We want to print tensile tests with continuous carbon fiber and minimize carbon fiber frays, which would damage the product strength and accuracy. We also want to produce reliable and repeatable results and easily maintain structure with user-friendly interfaces. So how does our system work? Our carbon fiber is coated in resin. The resin is then moved through the printer and through the print head. It is then extruded onto the print bed itself, and it's cut before the next layer begins. So our carbon fiber in resin, how it's coated, it moves through our resin bed, and it's moved through the matrix of resin. It is then deposited using a CNC nozzle, and interior structures can be modified for ideal loading using geometric optimization. The matrix is then cured, binding it to the fibers. The cured matrix is produced via UV lights and heated oven. So this is our pulling and wetting system for our carbon fiber. Carbon fiber tow is slowly pulled through the resin bath, and two sets of stepper motors pull the fibers from the spool to the extruder head. Extruder lays precisely fibers onto the print bed itself, and the UV LED cure the resin for tack cure, and the oven for cure. So our cutting system, if you look onto the top right, that's our CAD model for our cutting system, and the bottom right, that is the fully manufactured and machined final part by Matt Allen, and it must be cut. The fibers must be cut in between each layer. The system is mounted on the X-axis idler, so it's always vertically in line with the nozzle. The nozzle passes over the hardened insert, shear end stops, and it shears the carbon fiber. So for our safety concerns, the enclosure is made up of aluminum frame with acrylic panels. All interior sides are coated in 2 layers of 14 mil orange welding curtain to prevent any UV leakage. The removable front panel makes easy access to the printer while working on it, and a modular frame allows for any attachments in any orientation. So for our special considerations, implement a 2-stage curing process. An immediate tack cure is used on short range for flood UV LEDs, and a full cure is post-process using an AIBN and benzoyl peroxide resin matrix that cures at 60 to 80 degrees Celsius. This is great because it's easy to clean up post-printing. And here's our final product, a 3D printer that is capable of extruding and cutting resin impregnated carbon fiber tow, a modular system that can fit onto any desktop 3D printer currently available, synthesized resin matrix with minimal post-processing requirements, which means no printer cleanup post-processing, and a simple oven required to fully cure the part. Thank you very much. Thank you to Kate Gleason, College of Engineering, MSD staff, Dr. Amy Engelbrecht Wiggins, Damian McPherson, Don Poppel, and Mike Buffalo.